Okay, yeah, thanks. Thanks, Sid and Alexia for having me today, and for everyone for coming. This is fun. Hopefully, this will be fun stuff for you all. I titled my presentation "Towards an Improved Pipeline," which is hopefully not too soon to be making that joke as an Albertan talking to a bunch of BCers, but but no, don't worry. We're talking data pipelines and workflow pipelines here. So specifically for camera data in R. So that'll be the topic. Okay, so the roadmap today, I'll just briefly talk about who I am in my niche, and then you won't have to hear about me at all anymore. So I work at the ABMI, which is the Alberta Biodiversity Monitoring Institute at the University of Alberta in Edmonton. And I think I would consider myself more of a data scientist rather than an ecologist per se. So what I mean by that is that our organization, we collect a lot of data on a lot of different taxa, and that includes mammals, and we use remote cameras to monitor mammals. And so we get a lot of camera data coming in every year. And my job is to take that camera data, process it, and update habitat models that we develop. So as you can imagine, this is kind of a repetitive task, right? This is every year I'm kind of doing similar things. And so therefore my interest is in really developing that pipeline and making sure that those processes are as efficient as possible, that we're catching errors, and that I can free up my time to think about the science, the ecology, the biology, that kind of thing. So that's where I'm coming from. I am going to talk today about wildRtrax, and just with the caveat that that's the ABMI is associated with wildRtrax, so that's the platform that our data comes from, so therefore that's the platform that I use. I do want to just stress that that's just one available tool, and there's lots of great tools out there. And so hopefully this presentation stimulates your thinking around the tools that you use, and maybe how you can adapt what you use or combine, or that kind of thing. So I just wanted to caveat with that. I will be talking a lot about wildRtrax, but I think the lessons are applicable in other ways. And the third piece, which I'm most personally involved in and most fond about, is the wildRtrax R package that was developed by my colleague Alex McPhail and I. And this was just intended to be a companion package for users of wildRtrax to help the margins, to really to improve that pre-processing before data goes into wildRtrax, or help with the post-processing when it comes out. So I will be introducing that a little bit and showing you how I use it. And the fourth piece here is just, I want you, hopefully you can all be thinking about, what do you need? What are tools that you would like to see built? What are some obstacles that you find in your workflows? I think it'd be great if this community, if we're all in this together, and I think we can really build tools that all of us can use and access, and I think that would be really helpful, instead of all of us kind of working in our own little silos, which does tend to happen. But hopefully we can start to break down those barriers and converge on common practices. So that's the roadmap. So our focus today, so I think I didn't create this diagram, that this is taken directly from the R for Data Science textbook written by Hadley Wickham. This is kind of the whole game, right? This is, you're taking data and you're moving it all the way until you can communicate some scientific finding with it. And we're going to focus on what's affectionately known as the wrangle portion of this flow. So this is the import, tidy, and transform. And so I think most of you are thinking right now, oh my God, no, the boring parts. We're going to talk about the boring parts. We're not doing cool visualizations. We're not doing cool modeling. We're not going to communicate with fun pictures. I'm sorry. Sometimes we just have to dig into the details and get that part right, so that we can really focus on those other aspects later. And we might just dip into some viz at the end, just to keep ourselves sane. So I will put that little nugget out there, just a little teaser to keep you around. And I will say also, I've heard rumor that there will be another webinar brought to you by this group on more of that modeling process. So I think this is, maybe you can consider part 1 of that series, and there would be another next step modeling process next time, which would be great. So stay tuned for that. And I just want to add a little note here. We're going to get technical, and there's going to be code. And I think, 25% of you just kind of edged up closer to your seats. You're so excited, and 75% of you are already reaching for your emails. I'm sorry, but hopefully it's engaging enough. We just got to look at some code sometimes, right? So that's what we're going to do for this webinar. And I also wanted to say it. I'm sorry. I went through my presentation this morning, and I realized that this might be the first remote cameras presentation in history that has no cute animal pictures. And it's a bold strategy, right? but hopefully it'll pay off. But there's no cute animal pictures coming. I'm sorry. I know you've all seen a million of them anyway, so that you've been warned. Okay, my workflow biases. I'm just going to get out of the way here. Number 1 is, if I can, I want to do everything in R. And I'll just add the caveat that, obviously R is not the only tool. I am just explaining my own workflows here. People do amazing things in Python. You can do useful things in Excel. People use ArcGIS and all sorts of other pieces of software. My bias is that if I can do it in R, I want to do it in R. And that's really just for simplicity, right? I want it all in a single place that I can work in. And R is expanding all the time, and there's just brilliant functionality there now. And so if you're on the edge, if you haven't jumped into learning the R programming language, I strongly suggest that you do. It's really incredible, and especially for camera data analyses. Like I mentioned before, I'm going to show you how I use wildRtrax. But again, that is one tool of many. I think a lot of the lessons here can be cross-pollinated. So don't let that kind of just stick in your craw. Like I think that I'm just showing you what I use, and then there are plenty of other tools available that do an amazing job as well. And the last thing is that there are many flavors of camera data analyses. I know you all know that, and I will be the first to admit that I'm really only familiar with a small number. I'm familiar with a lot, but in terms of actual coding and using a lot of these methods, I don't do a ton of that. So I'm interested in your feedback about what kind of tools would help you in your camera data analyses. But I'm going to sort of show you a small subset of things that I think are broadly useful, and then we can build from there. Okay, wildRtrax. Dun, dun, dun. Okay, what is wildRtrax? I'm going to go really quickly here. This has been covered by other people and colleagues of mine who've built wildRtrax, and they know it way better than I do. But essentially, it's an online platform. You can store, you can manage, process, share your data collected by environmental sensors. So this is both cameras and acoustic recording units. Delivers multiple functions. It's really nice for collaboration, right? When you have a team of people that are working on something, because there's really good user and project management tools. It's got the storage piece. Obviously, that's a big problem for a lot of people. It's actually storing their data. The data management side, the database is incredibly well managed on the back end. So so it's really helpful to have it managed that way. Data processing. So this is that interface to actually do the tagging of your images, and of course the data export download function. And so that's actually, we're going to actually pick up on the final point here. We're going to pick up on the data export download function, because I think most of us, that's kind of, that's our bread and butter, right? That's what we're interested in. We want that data at the end of the day. And I will just plant another flag here on the data processing. So it's entirely likely that you prefer to do this tagging piece on a different platform, like time-lapse or something like that. And that's great. And often those tools are really flexible and they work for people. And so I just wanted to say that there are methods available to import not just your images, but any tags that you've previously made into wildRtrax, like sort of post hoc. and then you can take advantage of other things that wildRtrax offers. So I think there's some colleagues of mine on the call here that we can answer questions about that later if you're interested in that, but that is possible. So like I said, cross-pollination is possible. Okay, so like I said, we're going to pick up on the data export and download piece, right? So how is this done through wildRtrax? I'm just going to walk you really, really quickly through. I know it's boring. I just wanted to kind of show the mechanics, right? So you're logging into wildRtrax. Yeah, that's me. You're going to go to my data downloads, right? I'm interested in camera. Let's just say I'm going to take this first project here, Ecosystem Health 2014. I'm going to say next. I'm going to download the raw data. Pretty straightforward. It goes right to my downloads folder. I'm going to show you in the folder here. I got a bunch of crap in there. And so I'm going to extract all. You can see that I did this for practice a few times. I've been outed. So that's how the basic process works, right? So you've got it comes with 4 separate CSVs, and the one that you're interested in is probably this report one. And it's got it's just a basic CSV file, and this is all familiar to everyone. Each row is our image tag for each individual, tag for each individual image, right? Okay, so that's pretty common. Everyone knows how to do that. And so I say, okay, that works, right? That works. That's simple enough. But I'm biased, right? I'm biased. I mentioned that off the top. I think that tedious tasks, I think that qualifies as tedious personally, can be replaced with an R script. And I would say to you all that this is often a good idea when that task is prone to errors. And you might be thinking, like, how could I possibly make an error downloading a CSV from a website? And like, that's true. Hopefully you don't. But especially when we're managing a project with collaborators, I think this actually is prone to errors, right? Oftentimes we'll download the data, but then someone will actually want to go back and retag something or change tags, right? So then, you already have to go back and re-download that data. Maybe once you download it, you have to move it into a different file structure, or you have to rename the file. There are a lot of areas where this could be, this is prone to errors, right? And especially if you're working with collaborators who might not name the file the same way that you do, you're not really sure if you're working with the same data sometimes. So I will segue into the wildRtrax R package. Okay, we're getting into the good stuff here, I promise. So wildRtrax is an R package. It's not on CRAN, but it is available directly from the website GitHub. And so it's just as easy to download though. It's one line of code. I have it right here. And I will just say to everyone here, you don't need to be writing anything down. This presentation and all the code associated with it will be posted and available. So don't worry about trying to remember specific commands or anything like that. It'll all be posted for your reference. So the first thing is, of course, you want to install the package. It's easy enough to do with this one line of code, this one command. The only thing I will highlight here is that you want to add this little tag @main at the end here, and that just ensures that you're getting the primary branch, it's called, from the repository. So that's technical mumbo jumbo. You don't have to worry, just remember to add @main. And so once you've installed the package, it's like any other package, you can just attach it to your current R session with the simple command library, wildRtrax. So pretty easy so far. And so this is where the magic starts to happen. We can authenticate exactly like I showed you in the on the website. You can authenticate directly in R, which is super cool. And the way you do this is you set up an environment variable for both your username and your password. And that way that those values are just stored locally on your machine. And I just want to say quickly here, those values live only on your device, but be careful about including this kind of sensitive information in any script that you might inadvertently share, right? Even if that means you're just emailing a script to a colleague, or even if you post it publicly on a service like GitHub, right? You don't want to be including that kind of information on a script. So I have a quick workaround that I use. It's called the keyring package. I won't go into too much details, but it's basically like an encryption service where you can set certain values on what's called a keyring. You type them into a dialog box in your R session, and then that value will be stored on your own computer. And then instead of this top line here, you can actually just run this line. And of course, that's safe now for any script that you might be posting online or sharing. So if you have questions about that, we can chat a little bit about that, but I encourage you to kind of take advantage of services like that, which again, all in R, which is great. So authentication, then all you need to do is run one function. It doesn't even have any arguments. It's just called wt_auth, and you are effectively signed in to wildRtrax, which is really cool. And it doesn't look like anything happens. Like there's not immediate magic when you run this function. If you're interested, there are things that happen underneath the hood. This is all really sort of technical stuff. If you're interested, we can chat about it and you can play around with it a little bit. But basically, wildRtrax creates a hidden environment in your R session, and it obtains what's called an auth0 token, which is the privacy and user management service that wildRtrax uses. And so once you get this token, it stores it, and you can check out certain things like it expires within 8 hours, that kind of thing, and then you just have to re-authenticate. So like I ran this morning, so obviously this would authenticate for me around 4:45 Mountain Time later today. So, but the beauty of this is that you don't need to know that stuff. You can just run the one function and you're authenticated into wildRtrax directly from R. And so now you're thinking, oh, so what? Like, what's the big deal? Well, I think it's pretty cool because now you can actually interact with your data directly in R. You can skip all those steps. You don't need to go to data download. You don't need to play around with CSVs. And what I mean by that is that the functions in wildRtrax make use of that token that you've gotten, and they supply it to what are called what is called the wildRtrax API, which stands for Application Programming Interface, blah, blah, blah. Again, behind the scenes stuff you don't really need to know, but it works and it's really, really helpful. So for example, I'm going to highlight this function, get download summary, which basically just outputs to me a data frame of all the projects and their associated metadata that I have in wildRtrax. So if I run this, I assign it to this object, my projects, and I just take a look at it. I've got 41 different projects, and this is their IDs in the database, the associated year, and the number of tags in each, right? So that's pretty cool. That's a little handy reference. And the magic starts to happen when we use the download report function. So this is actually just exactly mimicking the data download on the wildRtrax website. And all you need to do is supply it the project ID value of the project that you're interested in. So for me, I'm interested in what I just downloaded before there. That was the Ecosystem Health Project from 2014. I can use the get download summary function here quite easily, and I don't even need to know that it is 205. I can just entirely script it and pull that value for myself. And so I know it's 205. And then wildRtrax download report, that's the function I need to just supply that 205. I tell it that it's a camera project, and then boom, I've got my data directly in R, and it's fast. It's just great. When you run it, it's there for you. No messing around with absolute versus relative paths or where you've stored your data or what its name is. Nothing, doesn't matter, right? It's just in R for you now to begin what you're really interested in, which is your analyses. So in this project, I have, just over 9,000, or not just, but 9,500 rows, which is a pretty small project, not a lot of cameras, and this is what we're familiar with, right? We have where it is, the timing of the tag, the scientific common name, et cetera, et cetera. And then, you can get creative, right? Like oftentimes, like for me, I've got multiple projects because I'm stitching together not just 2014, but 2015, but 2016, but 2017. So in this example, I'm going to use, we have a small set of projects. We call them our camera model comparison projects. I'm kind of running that same piece of code, except this time I want not just the 205, but I want 3 separate numeric values for those IDs from those 3 projects. And then I can iteratively run download report on those IDs and stitch them together all in one line of code. This could be done in a for loop. I'm choosing to use the per package, but R is flexible, right? There's many ways to do this. And boom, I've got in this case, I've got 51,000 rows, and it's those 3 projects all stitched together nicely in a data frame for me. So it's flexible, right? You can do, if you have camera data from multiple years or multiple projects you want to bring together, you can bring them together in a single command quite quickly. Okay, so I'm getting all excited over here, and you're sitting there, you're thinking, oh my goodness, like you've made a slightly slicker version of read.csv, like big deal, big whoop. And I hear you. I do hear you. I will just counter that. There are benefits to scripting, right? I talked a little bit about it before. Always get the most up-to-date version of the data, right? You don't know what happens to individual files on different people's computers. You don't know who's renamed something. You don't know if changes were made. Maybe some QA/QC was done and some tags were changed, but nobody ever told you about it, right? So it's really nice to just at the top of your script be able to pull the absolute most up-to-date version of the data from the database directly. And especially, if you're working by yourself, maybe not a big deal, but if you have collaborators, you really want to make sure that you're working off the same data. Reproducibility, a year from now, you might be wanting to run the same analyses. You want to make sure you're starting at the same starting point, right? And storage schmorage, right? Like I have 41 projects in wildRtrax. I don't want 41 CSVs sitting on my computer in various states of up-to-dateness. I don't want that, right? So storage schmorage, right? I just want to pull it directly into my R session when I need it. Okay, maybe you're half convinced now. Okay, now you're thinking, surely there are other more interesting functions in wildRtrax. And I will say, yes, there are. Okay, hopefully you find them interesting. I do. So let's orient ourselves back to this framework. We've worked on the import side. Let's move into the tidy and the transform side. And this is, I think a lot of people, I myself struggled with this for a long time when I was first learning. So I think it's natural, and sometimes you don't quite know what the transformations you need in order to make your models go or to visualize it. So there's a few tools in wildRtrax that'll help you now. And yeah, so let's work on tidy and transform. So I just want to say a huge shout out to the folks in the WildCo lab, specifically Chris and Mitch, who have put a lot of resources online onto their GitHub page, the WildCo GitHub page, and they've shared some of those scripts with me, and I've kind of, that's been the inspiration for some of these functions that I'm about to show you. So a huge shout out to those guys for getting that ball rolling, and hopefully that some of you will find this stuff kind of useful for your own workflows. So the the thing to remember here is that, that raw data, that's often not the final form that we want our data to be in, right? We need there's additional steps that need to be taken. And so one of the most common tasks among camera analyses is that we want to evaluate what are called independent detections, right? We want to be able to group those photos into an event. And, it might be a black bear that walks past the camera for just a single photo, or it might be a moose that hangs out in front of the camera for 300 photos over the span of 10 minutes, right? But oftentimes we want to kind of be able to group those camera detections logically. And there's a function in wildRtrax now for that. And it's called WT_IND_detect. And it's designed to work with the output directly from wildRtrax. So that's both a blessing and a curse right now, of course, because a lot of you won't use wildRtrax. So I think in the future, we're going to try to make this more flexible so that you can use it with data that you have. But right now, it's kind of designed to work tidily and seamlessly with data directly coming from that download report function. And the key point here is that you get to specify the detection threshold. So let's go back to our 2014 data. This is the new function. We're going to supply it with that data. And we're going to say, this is a common threshold, right? I want 30 minutes. I want to group my detections in 30 minutes. And there's a few additional parameters here you can specify if you want, human tags removed or domestic animal tags removed, etc. But if you run your data through this function, oh yeah, I guess I could have explained each of these individually, but yeah, you specify your threshold. And then what you get from that is another data frame. And this is a really nice summarized data frame with your detections. It's got a column called detection, which is just an ID associated with each of those detections. And that's sort of a nice launching step to different analyses, right? And it's just one line of code. And so if we did this with a threshold of 30 minutes, you get 307 detections. Let's test a new detection. Let's test a new threshold. We're gonna maybe say 45 seconds, right? That's a much narrower bandwidth. In this case, we had 377 detections, so not that many more. This is a pretty small data set, but yeah, you kind of get the picture. It's really flexible in that sense. So just a few lines of code and you can be kind of off and running here. And so I'm actually just gonna, oh man, the horror. I'm gonna actually jump into coding live on the internet. Wow, this is a monumental occasion. So I just have this first chunk here set up to do kind of what I told you guys before, just loading the packages, setting those environment variables, and then authenticating with the WT_auth function. And that took a little longer than I thought, but all right. Authentication into wildRtrax successful. That's great. So this is that 205. This is that ecosystem health 14 data. I'm just going to run this code so that I have the data directly in my session. It's going to tell me it downloaded 69 kilobytes worth of data. That's great. And I can just, here, let's just take a look at it so we all know what we're talking about. Here's those 9,000 rows. This is what your data looks like coming from wildRtrax. Cool. Okay, so let's go to independent detection function. Let's look at that. So we started out with a 30-minute threshold. I'm just going to assign that to the object T, and we're going to call this EH14_detections. I'm going to run that. It's going to let me know that it converted that date time column to a date. And yeah, here's that 307 observations, right? So we have that detection 1, 2, 3, 4 all the way to 307. It's going to tell me what was in the detection, the start and end time, the total duration of the detection, the number of images, and the number of animals. So pretty useful information. Hopefully you find it useful. So the last piece I will show you now. So this is, I would call it the main engine, right? So independent detections gave us some useful information, but we often needed to go a step further in order to like really have the appropriate format for certain types of modeling. And I'm thinking about, different habitat modeling if you're bringing in site covariates and occupancy, things like that. So we really want to evaluate, let's say, the number of detections in a specified time interval, for example, daily, weekly, monthly, and we want zeros to be filled in where detections didn't happen. So the star of the show is summarize CAM. So summarize CAM, there's a bunch of different arguments here. You supply the output from independent detections, you supply your raw data so that the function knows the effort level at each deployment, so the number of days that it was operational, the time interval that you're interested in, so that's your day, your week, your month, and then there's a couple different variables that it can spit out for you, including detections, but also something like presence absence if you really just want that 1, 0. And there's another little useful piece here. It's the desired output format, and that can be either wide or long. And I'll show you what those two things mean in a second, because they're useful in different ways. So this is what your typical call would look like to that function. You would say, this is my detection data. This is that, for example, that 45-second detection data that I just made. This was that raw data that I downloaded directly from wildRtrax. This is my time interval that I'm interested in. It's weekly. I'm interested in detections, and we're gonna have a wide output format. So let's go just quickly interactively and let's explore all these options. Close those. Okay. So that's exactly, what did I say? I said we wanted week. So let's start off with week variable. We're interested in detections, and we are interested in a wide format. So let's run that. And we get this new object, EH14_summarized. And so we have this new data frame now, which is telling us the week. This is a sort of a standard way to represent weeks in the year. It's called ISO week. It's based on some convention. Anyway, number of weeks since like January 1st, let's say. And it tells you the number of days of effort in that week so that it was operational for that full week. And then each column here now is our species, the species that we're interested in. And you can see this is pretty sparse data. There's a lot of zeros across the board. Oh, we got a 1, snowshoe hare, perfect. So here, let me just, moose. Okay, we had 7 detections of moose in the 26th week at this location, right? Okay, so that's a pretty useful format. And then this is something that I think a lot of us need to feed into different modeling techniques. So 1 line of code, you can get it. Let's play around here. Let's try, we just want month. Let's just do presence, and we'll keep it wide. How about that? Can run it again, same object. And now instead of that week variable, we have month. So these were the months that those cameras were operating, and same kind of format, nice and wide, as each of your species there. So the one difference I will show quickly is long. And long, if you can intuitively guess, is instead of having all those columns for each species, now you just have a single column for species, and then each row represents a different species. So instead of having, kind of a really wide data frame, you now have a very long one. And that's useful. I'll show you one really major way I personally prefer data to look like this, especially when I'm tidying, transforming, visualizing. But that's how you would do it. You just change that one parameter in the argument. Cool. Okay. All right. I've talked a lot. What gives people feelings of power? Well, weirdos like me, it's not money, it's not status, it's their R code working. Yes, that is the goal here. We want everyone's R code to be working. And so for me, this is the ultimate pipeline. I want, this is 10 lines of code, right? Like, it's a quick authenticate in, pull the data that I'm interested in, download it, and then summarize it for me. I want detections in 30 minutes, and I want it done by day, and I want it in a long format. And then now you can get straight into the science. And I think that's a key piece here, that a lot of us on this call, especially, are creative people. We want to test questions. We've designed our camera experiments, and we want to get into answering those questions. And I think, hopefully, I mean, some people really like to, like, we're like pigs in the mud, like we really like to slop around with the data. And some of us kind of want to be into that modeling piece more quickly. So hopefully this was something that could be useful to you in your workflow. It's something that I use and that is useful to me. And I will just bring us home here. I did promise a data visualization, and gosh darn it, I'm gonna do it for my own sanity too. So I'm gonna focus on moose here. I'm just gonna filter that raw data immediately for moose. I love moose. I'm interested in a really narrow detection threshold of 120 seconds. I'm gonna summarize that by month, just a really generic, a long time interval month, and I want it
working on it.
And I want it to be long. Okay. And then just a quick piece of just, I don't want detections by each camera. I actually just want to summarize. I want to sum up all the detections among those 20 cameras. So just another quick couple of lines there. And I've got my small piece of data, moose detections. This is partly due to effort, I bet. I don't think the cameras were available all the way throughout March, but we'll ignore that for now. You can see they kind of went up through those summer months. Perfect. Let's take a look. And the nice part about this is that it's immediately ready for, I think a lot of people here will be familiar with ggplot. It's a really awesome data viz package, and you can pipe that data directly into a ggplot call, and boom, you've got your data viz quite quickly. And this is not a very exciting data viz. Maybe I teased it a little bit too much, but that would be the pipeline. That's the workflow. So, okay, takeaways. Think of the pipeline. It may not be as important to all of you as it is to me, but that is kind of how I get more efficient at my job over time, and how I reduce errors is to build these things into code. I really love to automate these repetitive tasks with useful functions. If I didn't have to open up any other programs, I never would. I just want it all in the same R script. And I think open source is great. And I think I would really welcome any comments, contributions, ideas that any of you have of different functions that you think would benefit the community. It's been great working. I've worked with some of you already so far, and you've fed me ideas, and that's been just fantastic. And I think anything that we can build that is collaborative, and that people can make use of for free is good. And so, yeah, that was my presentation. Thank you very much. Thanks for staying on the call and listening.
Thanks, Marcus. Yeah, that was great. Even if you don't use wildRtrax, I think there are great takeaways about things that you want to think about, like managing data files within groups, and even as simple as seeing someone else's data tables. So you think about, like, how am I managing data, and like, how does that affect who I can use it? So thanks for that deep dive.
Yeah, maybe a bit deeper than some of you were hoping for, but hopefully, yeah, it'll just give you ideas.
Yeah, good for thought. Does anyone have any questions off the bat for Marcus about, or for the group? We do have a question that's come in. What are the advantages of this R package over CamTrap R?
Yeah, that's a good question. I haven't I once upon a time did do a delve into CamTrap R, and it didn't really suit the purposes that I was looking for at the time. So I unfortunately admit that I abandoned it a little bit. I didn't pick it up again, and I sort of just started developing tools that worked for my workflow. But I think it's worth a revisit for sure, and I don't want to discourage anyone from taking a look at it and seeing if that would suit their needs better. You know, it doesn't matter, right? You know, whatever tool works for you that you can trust is great.
Yeah, maybe if there's someone in the group who uses CamTrapper and thinks that they can speak to that either way, feel free to throw that in the chat for people who are curious. Mm-hmm. Great. So the question I had was, so you talked a lot about the data wrangling. And so what kinds of analyses do you do with this data? What are you focused on wrangling data to do?
Well, so for our pipeline at the ABMI, I just love that word today. I can't stop saying it. I swear I haven't said this word this much in like a year. Yeah, so we do evaluate those detections, those independent detections, and we set a pretty narrow threshold of 120 seconds. And there's a little bit more to the process than that, but so I do rely on that exact workflow, and we use an approach called time in front of camera to evaluate mammal density at each individual deployment, and then we scale that up over broader regions. So that's just one, like I said, flavor of analysis that we do. But like a lot of analyses, it starts at that same base, right? It starts at that same, we're tagging the images. We want to import it into our R session. We want to get independent detections. Like it has that same base. And I think from there, we all kind of branch off into different techniques. But yeah, that's what I use it for.
Thanks. Does anyone else have any questions right now? Yes. So the question is there a way to use the package, data transformation, et cetera, with data imported from sources other than wildRtrax?
Yeah, that's a great question. And the answer is soon. Yes. Like these are fairly new functions. They're not tested as well as I would like. And I'm hoping to work with a few of my colleagues to test them better. But yes, that is totally the plan. We want these functions to work seamlessly from data with wildRtrax, but they don't have to. And it would be great for users to be able to just supply their own data and the functions to be able to handle that transformation process. So basically that just means ensuring that the same type of information is in the data that you're supplying. Like, what's your timestamp column? What's your species column? What's your, there's sort of these idiosyncrasies that need to be handled, but that is totally the plan, is to make sure that these are available for CamTrap data that comes from a variety of sources.
Great. Here's a question. Since you envision users pulling data into wildRtrax, are there ways to alert users if a data set they have previously pulled has changed?
That's a good question. Yeah. I'd have to think about it. I mean, I think, yeah, it depends how large your data set is too, right? Because for smaller data sets, I literally in every one of my scripts, I am just pulling it fresh from the database immediately. doesn't matter if it's changed or not. There isn't really a penalty to that, except when the data sets do get big. And sometimes if it's like we have camera trap data sets that are over 800 camera deployments with nearly 1 million images, and that does take 30 seconds. It takes a bit of time to kind of pull from the servers. So yeah, you might not want to be doing that every single time, especially if you know that it hasn't changed. Maybe in that case you do want to store it. But that's a good question and something we'll think about for sure. Like if there's a way to cache that information and give you a little flag if, hey, you might want to re-pull this because something has changed. That's a really good suggestion.
I can ask a question. Thanks, Marcus. That was awesome. Something that I would love to know is if you could snap your fingers today and have one perfectly working function that would make your life easier, what would it be?
Oh, that's a good one. Oh man. I feel like something that would resolve all the naming issues among our deployments would be the #1 for me, because we've got multiple thousands of camera deployments that have naming conventions associated with them and in different projects as well. And sometimes that can be a headache, especially if you're pulling in, let's say, site covariates, right? Like you really want to be able to join and merge that data together, and it's a headache. So those kind of things, I kind of, it's more manual work than I would like. I think for me, like for our analysis, especially what I mentioned, that time in front of camera, I have functions associated with each component part of the analysis, and stitching those together into that pipeline is just really satisfying to me. And so just working on improving that is just kind of an ongoing goal, but it's pretty rewarding.
For the naming part, what would you advise someone who was setting up their data then? Is there some advice like new grad student, new project, you're saying underscores are the bane of my existence, don't ever use them? Or is there some way that you would give advice to help with that naming issue stuff?
Gee, that's a good question too. I am not, those naming decisions are out of my hands at the ABMI. I kind of take what's given to me. I think I have no personal vendetta or preference against underscores or hyphens. I would say don't use spaces. Don't use spaces. Spaces are, you'll run into all sorts of ugly problems. But I think, yeah, pick a naming convention that makes sense to you and try to stick with it. And make sure that you can build upon it, right? If you have more camera deployments coming in subsequent years, like make sure that you're accounting for that.
I have a processing question, and this is probably this is before it gets into the pipeline, but to use that pipeline, are you entering data on every image? Or are you doing some user definition? Like as you're processing, is there some user defined event that you're entering data on? So if a herd of elk are lining out in front of a camera and you can tell 13 animals walk by, how do you account for that? And then the independent stuff in your pipeline to tease those out?
Yeah, so that's a great question. The tagging process on wildRtrax itself, there are a lot of different ways that it can be done. There's you can go image by image and apply a tag of, this is what the species is, this is what its gender is, this is what its age is. You can do that image by image. Super tedious. I'm sure we all know that. There's what's called series view in wildRtrax, so that you can define that independent detection threshold directly on wildRtrax, and then it'll group those images for you visually on the platform. And then you can apply the same tag to all those images at once, so you don't have to go one by one by one by one. So yeah, there are definitely ways, and I don't do the tagging myself, but I know that there are people who are my colleagues who are extremely adept at doing it quickly. And then but the data that comes from the data download piece of it, it has that style of every row is an image, and each of those tags are part of that row in different columns. So it's sort of a predictable output format.
Okay, thanks. And then so from the pipeline process, then when you enter, like when you define your independence at like 120 seconds, is there some underlying stuff there to say if a different species walks by within that 120 seconds that gets captured as a separate event?
Yeah,
okay.
you bet. Yeah, you bet. It's evaluating. Yeah. I will say too, if you're interested, so there's help files available with all these functions. You can just type the question mark in the function name in the console, and you can read all about the different arguments and what they mean. You can also view the actual code itself on GitHub. It's all available publicly, so you can see the inner mechanics of it if that's your thing. And yeah, honestly, if you spot errors or if you spot things that you're like, hey, I actually want this to be different, like, please get in touch. I would love to hear what your purposes are and how it can be better. But yeah, you can dig into those inner mechanics if you want, and I can post a link to where you can find that on GitHub, or you can just search AB Biodiversity wildRtrax GitHub, and you'll find it immediately.
All right, we're getting down to the wire and want to respect everyone's time being here till 1. And so we have a question. What other R packages would you recommend for camera data processing and organizing? I.e. getting data from sources other than wildRtrax ready for analysis?
I would say, hi, Mariana, nice to see you again, or talk to you again. I had that cheeky little note in my presentation when I said that I prefer R, and I had the little footnote that said I generally stick to the tidyverse. And I know that I have some colleagues on the call who are just like losing their minds because they're such purists, and I totally respect that. But I love the tidyverse, and so Mariana, I honestly basically every script I start off by loading the dplyr package, the tidyr package, the stringer package. Like there's a couple workhorses in there that just are so incredibly useful that you can chain into these piped commands and do it really elegantly and quite succinctly. So that would be where I would start. Obviously those aren't camera trap specific. Those are just data, useful in data analyses. So camera trap specific. And then if we're getting into modeling, is a whole different kettle of fish, right? There's loads of specific packages that do certain types of analyses, like unmarked, and for Bayesian, like BRMS. So I think hopefully we'll have a webinar soon about maybe options in that arena and different packages that can support those analyses. But this was more about getting your data to that point where you can use those packages. So hopefully that answered your question.
Great, and that's maybe a great segue to wrap things up. And I don't know if Alexia, you want to speak to our hopes for the next webinar in the series?
Sure, I'll just thank everyone for coming today, and say to stay tuned for an email from Sid and myself about Chris Burns' webinar sometime in February. So stay tuned for a date and time on that and the registration.
Yeah, so thanks so much, Marcus. Thanks all the Marcuses who chimed in to listen.
Yeah, so many supportive Marcuses.
Yeah, thanks everyone for coming today. We look forward to seeing you at a future webinar. And again, get in touch with myself or Alexia if you have feedback on the webinars, webinar topics you'd like to see, how this could most serve you as a community of practice.
And I will, the code and all the presentation will be made available. I'll send that to Sid and Alexia, and they can share that so you can go over it at your leisure.
Great. All right. Take care, everyone.
Thanks.
Thank you.